Just a quick video here on number 46 in section 1-2. If you're not interested in this, no problem. You don't have to watch this video, but somebody's going to ask about it in probably each of my classes, and it takes a little bit of time to explain it. So just to recapture that time in class, we're just going to talk about it here on a video. First of all, in part A, it just gives us a formula, and we're simply plugging in a number that would represent the year 1988. So 1988 is 28 years after the year 1960. So we're plugging in 28. You're going to get about 180 million. 179.8, we just rounded that off, about 180 million. Okay. 2012 would be 52 years after 1960. Read the whole problem and you'll understand why I'm using those numbers. And you plug in 52, same thing, but you plug 52 right here, you'll get about 242 million. If you plug in 60, because 2020 is 60 years after 1960, you'll get about 263 million. Okay, now here's why someone would ask the question, is regarding part C. And to help you understand this, what I've done is just picked a couple of numbers over here that will hopefully bring some context to the problem. Let's suppose that the number of eligible voters in some other country, is 75 million, and then let's suppose that 60% of them actually vote. That's a reasonable number, I believe. I don't know exactly what they are in the United States. In fact, it seems to be changing based on the year. That's the formula these are the two formulas that were being given, the two expressions, I should say, that were being given for this number 46. But if it were a population that has an eligible voter population of 75 million and 60% vote, what you would do is you would change 60 to decimal, 0.6, and then multiply those numbers. 0.6 times 75 would be 45. That means 45 million people actually voted. Let me just say that once again. If you have 75 million eligible voters and 60% of them actually vote, you would take 0.6 times 75 and get 45. 45 million people actually voted. Okay. Now, that's not what we were given, though. We were given expressions. So you've already worked with this one if you've answered A and B correctly. Then they give us this new formula that is this one that gives us the percent of those who vote. Again, it's based on year. And the first thing we would need to do then is change that to decimal. Now, to change something to decimal is like multiplying it by 1/100th or by multiplying it by 0.01. And you probably thought of it as moving a decimal in the past, and that's true too, but you are going to move the decimal on both things, right? There's two terms here, so you're going to move the decimal left for both of them. That would make this negative 0.003 y plus 0.61. Okay? And then the number of voters, I don't think I can really fit it there, so I put it down here. This right here would go there. Okay? Just like you multiplied 60% as a decimal times 75, we're going to have to multiply this percentage by this number. And that's what I've done here. I've done the math on it already, so I did FOIL to multiply those out. And then combine like terms. These are alike, so this is what you'd get. This expression right here is the answer to part C. Okay, that's where the fun really is, right? In part C. Okay, and then D. If you got through C, then D is going to ask you about the year 1980. So how many people would we expect to vote in 1980? Well, that would be what you get when you plug 20. Because 1980 is 20 years after 1960, when you plug 20 in for y into this place and do your math correctly. This is 20 squared, right? So this is negative 0.0078 times 400 plus 1.265 times 20 plus, and I did that on my calculator. I got 87.45 to be specific. I looked at the answer that they listed on the answer document, and they rounded it down to just 87 million, approximately 87 million. Okay, thanks for tuning in.